earthquakes. And as mentioned by Dr. Nanjan Swami, the topic I will be speaking about is earthquake disaster management. Just to tell you, I had no idea about earthquakes until I went to Japan. I went there for doing my PhD, and I went to Tokyo University. I was there in Japan during my PhD days from 1993 to 96, 3 years. And I learned, especially in Tokyo University, all research were in earthquake engineering. Whether one is a doctor, one is an engineer, one is an electronic engineer, or somebody from social science management also, they would do something related with earthquakes. And that was the kind of importance given to earthquakes. And during my stay, probably I must have experienced at least 6 earthquakes. Luckily for me, all of them were not big enough to cause any panic. Still, during those times, those 5, 6 earthquakes which I experienced, every time I experienced, I was vulnerable. I was most of the times at my home, which was on the 7th floor. And on 2 occasions, I was in college and I was in the cellar floor. And all the time, I was really panicking. I was really not sure what was happening. Luckily, the earthquakes were not big enough. And because of my, studies in doctoral program in earthquake engineering, I had the opportunity to visit 3 earthquake sites after about 3 to 4 months, 1 in Japan and 2 in India. So Japan, 1995, there was a big earthquake in a place called Kobe. And 2 in India, 1 is in Gujarat in 2001, there was an earthquake. And another earthquake which caused tsunami, it was in 2004, December. And I had the opportunity to go to Andaman Islands in 2005, April and May. So I'm just mentioning this because, my research at Tokyo University took me along, and this field has been my pet field, and I have delivered many, many lectures. I developed, as mentioned by Dr. Nanjan Swami, Earthquake Engineering Laboratory at my earlier college. And so I'll be very, very pleased to talk to you all on the disaster management related to earthquakes. I'm told we are almost at the end of this program. That means you are already given enough of knowledge about disaster management. So my focus will be on earthquakes. And naturally, you people are in diversified fields. I'll be more focused on, showing you pictures rather than, talking about the technical aspects, equations, and so on. And, this online program, probably 4 or 5 years back, nobody used to enjoy. But after the pandemic, we all know that such online programs are very useful, and you can really concentrate and get as much as you want from these online programs. Therefore, I want you people to, ask any question at any point of time. I'll be very, very pleased. And let us try to have this class as a more interactive one, which really helps you people also to be concentrating more. And I also feel that, I'm not teaching online. See, earlier days, just to speak in front of computer looked very silly. But nowadays, we know that, there are people on the other side. Therefore, things are different. So, I request all of you to keep your microphones muted so that there is no disturbance. And I presume that the audio and visuals are perfect. Anytime you have any problem, kindly let me know. In general, infrastructure is the order of the day. Every one of us will want good infrastructure. Fortunately, in India, infrastructure has been developing day by day, and we are planning to be a developed country by 2047. Viksit Bharat. And if that has to happen, our infrastructure should be good. And what is infrastructure? As you see here, it could be road infrastructure, it could be buildings, bridges, it could be, anything related with air travel, anything related with rail travel, anything related with, energy generation, electricity generation, and so on. All these will have to be intact under all circumstances, including unexpected situations like, some kind of a disaster, earthquake, flood, or cyclone, and so on. So we need to keep them, well maintained, and if necessary, they need to be improved upon, and there needs to be a new infrastructure to be created, and so on. And these infrastructures are the ones, which may cause problem during big disasters like earthquakes. We have to be extremely careful. One of the biggest challenges most countries are facing, and especially India, is urban population. And therefore, the infrastructure has to be intact. Just to give you statistics, when we got our independence about 75 years back, our population of the country was about 35 crore. Only 16% of 35 crore lived in cities. Rest lived in villages. Our country was, country of villages where agriculture was the main occupation. So 16% of 35 crore amounts to about 5 crore, 5.6 crore. Today, scenario has changed. We are the most populous country. Approximately about 145 crore is the population. And more than 40% of Indian population lives in city, which amounts to about 60 crore. So what it was less than 6 crore 75 years back has now come to about 60 crore, 10 times. The cities remain the same, maybe slightly they have expanded, but each of these cities is on an average, having population 10 times more. And few more years, 10, 20 years more, it could be 15 times more. Are we equipped for it? Do we have the infrastructure for that? If there is any disaster, are we in a position to take care of the situation? Are we in a position to control the situation is a biggest challenge. And government has been addressing all these challenges, but all of us needs to be very careful. Luckily, there has not been big earthquakes in the recent past. But if there is any disaster, not only earthquake, and especially if the disaster hits a most populous city, congested city, we don't know how things would be. See, globally, we have cities like this. I could have put Indian cities, Indian picture also. I didn't want to put. This is the capital city of Venezuela, called Caracas. Looking at it, do you feel like, living in a city like this? It looks so vulnerable. You feel as if there are no greeneries around. Each of these buildings looks old and delicate, sensitive. There doesn't seem to be, road at all. Therefore, roads are very, very narrow. Completely covered with buildings and no open space at all. Each of these buildings is 1, 2, 3-storied, very regularly built. We don't want to live in such cities. Imagine if there is any disaster, even if there is an accident. I don't know whether there will be scope for ambulance to move on the roads freely. There will be scope for fire engine to move. These are definitely very vulnerable cities, and we have to be careful. If there is any disaster happening there, we are not sure how disastrous it can be. We are not sure how many loss of life we may have. So we in India also have many such cities, and at least there are cities in which some portions are something like this. We have to be extremely careful. In general, we need to think about cities or our resources which are sustainable. We have to be very careful about our resources. We should not lose them, including the existing buildings. We have to think about economy, no doubt, but then safety is equally important. We need to think about safety during construction, safety during maintenance, and safety during even removal also, which is extremely, extremely important. We need cities something like this, which do not look to be overcrowded, which have huge amount of natural surroundings like greeneries and water bodies, which have lot of open spaces, good transport systems, alternative systems, train service, bus service, road service, and so on. And that requires planning. That requires enough space. That requires resources. And that's what is the requirement overall from the development point of view. Well, in India, we should be really proud that we have many, many infrastructural projects, whether it be tunnels, roads, airports, bridges, railway tracks, and bridge dams, and so on. And each of these will cost several lakh crore rupees. And if you see any budget of India, almost about 30% of the amount is towards infrastructure, either directly or indirectly, which shows the importance for infrastructure, which shows that if we have to be Viksit Bharat, developed country, we need to first take care of the infrastructure. A lot of policies have been tried by the government to see that the cities are, going in the right direction. You all are familiar with, the concepts of smart city. About 100 cities are made smart cities in the country, out of which 7 are from Karnataka. And the objective is to see that IT is incorporated, and hence life of people is made much more comfortable. And the clean city, Mysore at one point of time was the cleanest city. Now it has given place to cities like Indore, Vishakhapatnam, and it's among the clean cities. Main emphasis is on.
Jadhav sir, mute ಮಾಡ್ಕೊಳ್ಳಿ ಜಾಧವ್.
ಇಲ್ಲಿ ಸೈ ಅದ ಅವನು ಸರ್. Jadhav sir, ದಯವಿಟ್ಟು mute. Good. Where main emphasis is on waste management. There is also this concept of safe city. Safety against all odds. Safety against law and order. Safety against, any kind of accidents. It could be in road, or it could be even in an industry. And safety also from the point of view of disasters. If there is any disaster like an earthquake, flood, or cyclone, the city should be safe. And of course, we should have very good healthcare system, wherein even if there is some injury during disaster, people should recover very fast. So lot of policies have been thought about with an intention to make the life of human beings, citizens, comfortable. I just would like you to look at the World Risk Index from the point of view of natural disaster. If you look at India, we stand in the 90th place out of around 181 countries. That clearly shows that we are better than maybe about 90 countries, but there are about 90 countries above us, better than us. If we have to say that we are looking at Viksit Bharat by 2047, naturally we should be at the top. Therefore, there is enough scope for us to improve from the point of view of disaster management. Here, the details about the top countries and bottommost countries are given. And highest risk is 100, lowest risk is 0. If you see countries like Qatar, Malta, and several others have very, very low risk. Qatar has risk index of 0.3. On the other hand, countries like Guatemala, Papua New Guinea, Philippines are on the highest risk side. And India, having a risk index of 6.65, is in the 90th position, which clearly means that we are better than many, but there is a lot of scope for us to improve. I now would like to take you on to several earthquakes which have hit the globe, in different times. Mostly, I'll take you on to some of the recent ones. This earthquake happened, about 2 years back in Turkey and Syria. Some terminologies I'll be talking about, and I would like you to collect these terminologies, and they will help you to understand much about the disaster, how disastrous a particular earthquake can be, what are the factors which make the earthquakes disastrous, and what is that you people need to do in case of crisis. So magnitude is one aspect which you should know. 7.8 is a fairly big value. Anything around 8 is very big earthquake, and that can cause huge amount of damage. The other aspect is, I have mentioned here, depth. So clearly it is focal depth. And what is focal depth, I will talk to you in one of the slides later. And it is 10 kilometers, which is a very small value. Anything less than 25 kilometers is dangerous. Smaller the focal depth is, the bigger is the damaging effect. And then epicenter is the location on the ground surface where the earthquake is first felt. Okay. And that also definitely lets you know how disastrous a particular earthquake is at a particular place. So the problem with this earthquake, which happened on 6th February 2023, was that more than 50,000 people were killed, both in Turkey and Syria. And, on the right, you see the pictures. I just put those pictures, okay, which tells you about the power of earthquake. You can see what has happened to the road. Road is simply sheared into two parts. Okay, somewhere here, this portion of the road has moved to the left and this portion has moved to the right. See what has happened to the railway track. It was a straight line, and it has now twisted so much. And, it shows the power of this earthquake. It shows how the ground moved. On the left side, you see the map of Turkey and Syria, and you see many dots. Only 2 are red. Rest of them are, yellowish. And the magnitudes are mentioned here. You can see there are a number of earthquakes which have happened across Turkey and also a little in Syria. Out of which Two of them are very, very big. Both these earthquakes had magnitude close to 8, and both of them happened on one single day in the month of February 2023 in a span of about 9 hours. The distance between these two is more than 100 kilometers. It is very unusual that two big earthquakes happen on the same day. But there can be, a big earthquake today, and after some time, another big earthquake little later. Usually, there will be many earthquakes before and following such big earthquakes. Those which are, which do happen before are called foreshocks, and those which happen afterwards are called aftershocks. What you see here is many, many aftershocks of these earthquakes. And the cities around these, red dots, were severely damaged, like the ones you see in the picture. Very interesting fact is that there is one city called Erzincan, very close to these red dots, which never suffered any damage. There were very minute damages. One mosque, one of the minarets of the mosque was slightly damaged, which is an old mosque. Okay. Otherwise, absolutely no problem. There was absolutely also no death reported. And city proudly claims that this is all because they strictly follow the bylaws of the region. Whatever corporation says, everybody adheres to it. And city also has a very organized bylaw guidelines. So friends, what message I want to convey to you here is that if you are looking at disaster management, the simplest thing is follow the rules. Every one of us will have to follow the rules, and rules have to be formulated in such a way that it is not going to disturb. It's not going to cause confusion. It's not going to be laborious. And if that happens, there is no need for serious work towards disaster management. Please note, Erzincan city was very close to the, we call it as epicenter. Therefore, there was every scope for it to be damaged severely, every scope for it to lose many lives, and neighboring cities suffered serious problem, but not this city. And this is what I want you people to keep in mind. This is how the Erzincan city looked like before and after the earthquake, without any damage to any of these structures, any of these buildings. Normally, I try to show this picture of World Trade Center collapse way back in 2001. All of you have seen that, Yeah, please keep yourself muted so that, there is no disturbance.
Saudagar sir.
Yeah. So all of you know what happened there. Two of the aircrafts hit the two towers, and you know the consequence of that way back in 2001. The beauty about this building's collapse is that, number one, it did not collapse immediately. It gave about 45 minutes time. Number two, the two towers collapsed such that they did not fall outside. All of them, fell inside without causing problem to the neighboring structures, which were also very tall structures. This is in New York. You know that, it's in the middle of the busy area where many tall structures existed, and nothing happened to the neighboring structures. And it gave 45 minutes time for people to come out. That concept in engineering we call as ductility. This much time available was sufficient for many of the people to save their lives. I think about 5,000 people died. Most of them, were above the place where the aircrafts hit, and they didn't have scope to come out. But what is important is many people survived. If by chance the building had collapsed immediately, number would have been, instead of 5,000, at least 50,000. Why I am saying this is, such a construction we call as ductile construction. It is very essential in earthquake prone area. So we always say that building should be so built such that if there is an earthquake, you should have enough time to come out of your building and see how the building is collapsing. So whenever there is a small earthquake, there should be no problem for the building. But whenever the magnitude of earthquake is very big, it's very difficult to save that building. But the building should at least stand for a while in such a way that people are able to come out with their precious things, with their children and so on. And then, if it collapses, well, we can't do much. So such, a term we call as resilience. Resilience is very important in disaster management. So resilience is, how quickly. So resilience is a good word as to say, from the point of view of disaster management, how quickly you can come out of the problem. So one of the important things is that, you need to save people, save lives. Therefore, building should not collapse immediately. 2, immediately you should be able to bring back normalcy. And that's a very important requirement from disaster management. So, this is what I say. You may not be able to stop the collapse, but you at least can be able to, can control the speed of collapse. October 13th is called the International Day for Disaster Reduction. All these is only to create an awareness. Well, friends, so this was a general introduction. And now I'll be showing you more about different earthquake disasters, all through pictures. And slowly, I'll try to tell you how an earthquake can cause a dynamic force on structures, and hence, some of the fundamentals of disaster management related to earthquakes we'll discuss. If there is time, I'll probably talk about how you need to build a structure from earthquake resistance point of view. So this is what I'm going to cover in the next 2.5 hours or so. Well, friends, here you see a road embankment. So you see, the ground there is a sloping ground, and one side you need to fill up, and hence, it is an embankment. It was built, a 2-lane road with shoulders on either side, with an intention to carry the vehicles. Vehicles were moving comfortably, and suddenly earthquake happened, which caused a damage somewhere in the middle like this. So this was a picture taken during the 1995 earthquake in Japan, which I talked about, which I said, I had the opportunity to visit and see what kind of failures happened. So here, we are not sure this damage has happened. That means, all these vehicles are totally stopped. They cannot move on this road until this is repaired. And why this damage has happened? Very difficult to say. Why only here? Very difficult to say. But our job is to see that it doesn't happen again. Our job is to identify why this happened only here. And our job is to see that it is repaired immediately so that the vehicles can move. This is what the common people will have to do before the next earthquake hits, because we need to show such improvements. And this is what is very essential from the disaster management. Well, I'll take you on to this earthquake, Bhuj earthquake, which happened on the Republic Day about 25 years back in 2001. The magnitude of this earthquake was 7.7. Focal depth is 16 kilometers. I want you to note down this point also. And there is another term, intensity. And intensity, I say 10x here, 10 in Roman 10. And intensity is measured in mm scale. Mm stands for modified Mercalli scale. I will talk about all these things. What is magnitude, what is intensity, what is focal depth, and so on later on. But at this point of time, as I told earlier, whenever magnitude is around 8, I would say 7 to 8, it is disastrous. Whenever focal depth is less than 25 kilometers, it can cause serious problem. And whenever the epicenter, so what is epicenter? We'll see a little later, is close by. Epicentral distance is small. It can cause very serious problems. And when these problems are created, more problems are created, they are identified by the intensity. Intensity talks about the damaging effect. And whenever the intensity is more than 9, it is from scale 1 to 12. Whenever the intensity is more than 9, it is very, very damaging. So this earthquake, quite naturally, was very damaging. And fortunately, this was the earthquake which created awareness among everybody in India to have a control over disaster management. Until this earthquake, again, there was one more disaster, cyclone in 1999 in the eastern part of India, which killed about 10,000 people. So 1999, around September, October, that happened. And about 14 months later, this earthquake happened. Then government decided disaster management should be the most important thing we have to consider. Two important organizations were set up at the central government level. One is called NIDM, National Institute of Disaster Management. And the other one is NDMA, National Disaster Management Agency. And the disaster management was taken up by the Prime Minister directly as the head in the central level and Chief Minister as the head at state levels. For the districts, District Commissioner is the head. This is how disaster management importance to that was given. And if you look at this earthquake, naturally, any earthquake becomes popular when the disasters, the damages are more. We normally talk about the damage in terms of loss of life. I say here approximately 20,000. Official figure stands at something like 16,000 something. And then injuries, how many people are rendered homeless, how many houses are damaged, how many are destroyed, how many cattle are dead, and what is the damaging loss in terms of US dollars. So this is one of the worst earthquakes to have hit India, having nearly 20,000 casualties. So some pictures from here. On the left bottom, you see a village which has been totally destroyed. Every hutment here is totally destroyed. The name of the village is Bachao. And I'm very, very sure at the time of the earthquakes, people were shouting, screaming, and requesting for help, saying, "Bachao, bachao," and so on. On the right top, you see a town called Rapar town. And you don't see a town here. You just see rubble. That is the power of earthquake. Every house has been totally destroyed into rubble. Maybe far off, you might be able to see a couple of houses, but these are also very, very severely damaged. You can see some here. They are also very, very severely damaged. This is how the earthquake was devastating. Even in the city of Ahmedabad, which is more than 200 kilometers from the epicenter, from the earthquake point. Normally, when you are too far off, the effects are less. There were about 2,000 deaths, 100 buildings, all of them built in 1990s, only 8 to 10-year old. They were destroyed. You can see in the picture, all of them were destroyed. And, you can give explanation as to why that happened. It clearly shows that earthquakes are totally unpredictable, uncertain. They may cause some problem in some place, neighborhood, there may be no problem at all. And that's what I'm trying to show you. So they are totally unpredictable. You cannot expect when the next big earthquake happens and what kind of damage it can create. I always make it a habit to talk about this earthquake, Haiti earthquake. Haiti is a very small country in the North America, just to the southeast of United States of America, just below Florida. Lot of small islands are there. Some of them are West Indian islands, which we are familiar with. There is also Cuba. And this island has two countries, Haiti and Dominican Republic. Haiti has its capital called Port-au-Prince. It's a port city. This earthquake happened again in January, 12 January 2010, about 15 years back. It had a magnitude 7, focal depth 13 kilometers. And what I want to address here is that number of deaths this earthquake caused. Please note, friends, the population of the city, Port-au-Prince, was 30 lakhs. Out of this 30 lakh people, 2.5 lakh people were killed and about 3 lakh people were injured. And when I say injured, they were seriously injured. And probably they will never get back their normalcy. Which means, almost 20% of the city was either killed or, severely injured. 1/5. So you can see the impact. You can really feel the impact. And this is how the residential area in the city looked like. Every building was destroyed, not just damaged. You can see so much of the building remains, were seen on the floor, on the ground. You can see how the central business area looked like, central city area looked like. Every building is severely damaged. There is no way you can repair them. If you want to use that space, first you need to dismantle that entire building, remove all the debris, and then restart afresh. So this is the kind of destruction that earthquake caused. Please note the magnitude was 7, not very, very huge. And this shows the road infrastructure. Can you use this road? See the kind of impact this earthquake has created. This shows how a typical type of building called frame structure, columns and beams, was destroyed, and another building which is built mainly out of walls, masonry, also very seriously damaged. Normally, we say that, VIPs buildings are generally built very strong, so they survive disasters. In this case, even the even the palace of the president could not survive. The dome you can see has been damaged. That's the kind of impact this earthquake created on Haiti. And you can have a feel about how the citizens would be. So these youngsters had no idea what their future is going to be. They were really panicky and they had absolutely no idea about their future. And maybe they already must have lost a couple of their very close relatives. And in their background is the debris of the fallen buildings. So you can imagine the psychology these people, these children, these young people will be having, and what kind of impact they will have on their feelings. Many indirect problems do happen after a disaster, like an earthquake. One such indirect problem is fire. Mostly big earthquakes always cause fire. Fire is caused either due to short circuiting of an electric connection.
Namaskar, sir.
Or sometimes, the gas leakage. And in this case, the fire happened. There was no scope for extinguishing the fire. For weeks, the fire continued to ruin the entire city, which was already severely damaged. Because, there were no firefighters, there were no, fire engines or anything, no fire personnel, because either they had been killed or they were injured severely. They didn't have scope to come out at all. So many indirect happenings like, fire, they continue to burn for days, which happened here also, and already damaged, and this will create even more panic. The other biggest problem was dust. Please note, it is not the earthquake which kills people, it is these buildings which kill people. So all these buildings collapsed, causing so much dust. And this dust remained in the environment for months. People there had to consume this dust. You can imagine what will happen to their lungs. Children, old age people, they were just made to consume this dust, and this dust remained in environment, for days, naturally causing huge amount of pollution. And the worst part was that even after a couple of years, nothing was done. They had not even removed the debris. That is the kind of disaster management this country had, or even now this has. Almost all the buildings were damaged. They had no scope, they had no facility, no infrastructure to even remove the debris. So imagine what will be the fate of people. For years, they will keep on seeing that shabby things, very old, broken buildings, and how their psychology could be. So that's why I always try to talk about this earthquake and tell that you should have an idea about what is poor disaster management. So in this case, it was one of the poorest disaster management. Naturally, it decreased the capacity of the city or the area, and it increased the vulnerability. So we don't want such disaster management. Always, comparison is good. Here I'm trying to compare three cities or three countries, sorry. Haiti, just now we saw. India, I showed you that Bhuj earthquake. And I try to consider Japan because I know disaster management in Japan is one of the best, especially earthquake disaster management. I want you to compare these three. I have chosen those earthquakes which are of similar power, similar strength. So I have considered earthquakes of magnitude 7 and 8, around 7. And from same distance, about 15 kilometers focal depth. Look at the damage. Already I told you, Haiti, something like 2.5 lakh people were killed. On the other hand, similar earthquake, similar power of earthquake, but only 20,000 people were killed. I'm stressing here only 20,000. Not good to say, very casually 20,000 people. So how many very, very important people, how many lives we lost, okay? But compared to Haiti, where it was 2.5 lakh, here it was 20,000. So question is, why? There will be many, many reasons, but one reason I always talk about is the quality of disaster management. Quality of disaster management in India was much better compared to Haiti. So many casualties and so much is the, problem with the disaster. Bringing back normalcy took long time. Years it took. On the other hand, in India, things were better. But as I told earlier, look at Japan. Japan is one country where earthquake disaster management is very, very good. Because, they keep expecting big earthquakes to happen. And look at the number of deaths during different earthquakes. Please note, in India, 2001, this earthquake happened, and after that, we are free. Maybe for several years, we will not have a big earthquake. But look at Japan. Every year, they have big magnitude earthquake, at least one, sometimes even two. I'm trying to show here, in 2006, number of deaths were 0. 2007, 1 death, 8, 12 deaths, 9, 0 death, 10, 1 death. During a similar earthquake of magnitude 7 and above, and focal depth of 15 kilometers. Why so less in terms of number of deaths? It's just because of quality disaster management. So one thing very, very important is that if the disaster management is good, there will be definitely good awareness among people as to what they need to do before, during, and immediately after the earthquake. All the concerned people will know their responsibilities. Doctors know what kind of treatments are necessary if people are hurt. Engineers know what they will have to do to their buildings before, during, and after the earthquake. And thereby, you're going to think about good disaster management. So what is disaster management? Many people would have covered. 3 very, very important things you should know are: number 1, loss of life should be minimum. If you can make it 0, excellent. Number 2, economic loss should be minimum. You should not lose too much money. For instance, in Haiti, whatever happened, it has put that country low behind by more than 2 decades. So 2010, this earthquake happened. Even at 2030, they will stand at where they were at 2010. No growth at all. And the third most important thing is how quickly you bring back normalcy. School children should go back to school immediately. Office going people, business people should start their work. Roads should be repaired. The mobile connection should be working. Good drinking water should be available. Electricity should be brought back. Gas connection, everything should be intact. If any repair has to be done quickly, it should be done. So, people will not be panicky. So this is what is very essential from disaster management, where Haiti totally failed. Japan is one country where things are better. India stands somewhere in between. And we have to not follow Haiti, but go towards Japan. And that's where the challenge is for all of us. I have tried to show a number of fairly big earthquakes all over the globe, scattered all over the globe. You can simply see wherever the number of deaths is less, look at which country it is. That country provides good disaster management. Wherever the number of deaths is more, that country is poor in disaster management. You can easily make out from this that, places like India, Sumatra earthquake in 2004, and Taipei, Turkey, things are not good. On the other hand, countries like New Zealand, Japan are good and earthquake resistant construction, earthquake engineering, earthquake disaster management. Purposely have shown the first one, Tokyo. You look at the number of deaths overall, wherever number of deaths is small. For instance, USA 1 and Japan 1, and the last one is New Zealand 185. These are the countries which have good earthquake disaster management. All the rest have to improve. And the first one I have shown is in Tokyo, wherein the casualties were 1.23 lakh people killed. Look at the year. It's more than 100 years back. During that time, disaster management, especially earthquake disaster management, was still poor. It had not improved. And hence, so many deaths. And out of these, more than 50% died because of the fire accident. They did not have, enough resources to control the disaster due to the fire. So overall, if you have good disaster management, if you give importance to, manage the disaster, you will save a number of lives. Naturally, economic loss can be reduced, and hence, you bring back normalcy early. Therefore, you will not have a feel of the disaster much. On the other hand, whatever happened in Haiti, even today, the similar situation continues, already 14, 15 years back. So, I talked about urgency in Turkey. I told you that because of the good guidelines, because people follow the bylaws, things are good. I talked about the earthquake disaster management and told that Japan is good in quality disaster management, where awareness to people is good. They build their structures, strong and safe, and they know how to manage during the crisis period. Therefore, the disaster management is good. So whenever disaster management is good, you will control the loss of life, you will control the economic loss, and you will bring back the normalcy at the earliest. One more disaster which you should be knowing about is tsunami. Tsunami we had never heard of, until 2004 December, when a big earthquake struck in Indonesia and caused almost 2.3 lakh deaths in 14 countries surrounding that. Majority of the deaths were due to tsunami. So very quickly, we'll try to see what is tsunami. Mostly, tsunami is caused by earthquake, a big earthquake which happens in deep sea. It's caused by big earthquake which happens in deep sea. Sometimes, tsunami can also be caused by volcanic eruption. But majority of the times, big earthquake at the base of the sea, at the bed of the sea, which may cause the tsunami. What will happen during tsunami? there will be huge waves which are generated and which will move into the land. And these waves are created because, at some depth, at some distance inside the sea, the earthquake would have happened at the bed of the sea, which would have disturbed huge mass of water. The depth of water in deep sea can be even 10 kilometers, and 10 kilometers of water will be lifted up, brought down. So much of energy release would have happened. So that gets converted into kinetic energy, and hence, this will cause the waves to travel at a very high speed of an aircraft, about 600, 700 kilometers per hour in all directions. And these waves move at such a speed, and when they hit the shore, this kinetic energy speed is converted into potential energy and waves are generated. So at the shore, huge waves of height 10 meters, 15 meters, 20 meters, 25 meters is generated, and these waves hit everything that obstruct them. It could be a tree, it could be a building, and if that building survives, that time it is okay. And if not, that is moved either, more towards land or back to the sea. And we'll try to see some of the tsunami effects in the next pictures. So this is how tsunami is created. So at the bed of the sea, earthquake happens, earthquake lifts the entire mass of water up and brings it down, causing the waves to travel in all directions and hit the shore, causing bigger waves. You should have a idea about, the ripples that are generally created, the wind waves that are generally created, and tsunami waves which are created. So wind waves generally cause ripples, small, waves. On the other hand, tsunami will simply allow gush of huge amount of water at a stretch. And I would like you people to have a look at a small video which talks about or which shows you how ferocious a wave can be and how it can cause panic among people. Sits in some coastal tourist place. Luckily, no damage done. Both the statue and the building have survived. But have a look at the way the waves come. It's not just one time it comes, a series of such waves, 4 times, 5 times they come. Okay. Just wanted you people to have a feel about it. So that is how tsunami is created. And this earthquake in Japan in 2011 is very famous because the magnitude of earthquake was very big. Still, it is not the earthquake which caused serious problem, but it is the tsunami which caused serious problem. We'll try to see. Initially, I told that there are big earthquakes which have not killed many people in Japan, but let's see what happened here. Japan is a country of many islands. 4 big islands are Honshu, which also houses Tokyo City, Hokkaido at the top, and Kyushu and Shigoku at the bottom. And there are hundreds of other smaller islands. So Tokyo City is here. This earthquake happened almost 300 kilometers away in deep sea to the northeast of Japan, northeast of Tokyo. The closest city to this earthquake is Sendai. And please note that the magnitude of this earthquake was 9. Intensity more than 10, we will try to see that. And more than 350 kilometers to the northeast of Tokyo. It had a focal depth just less than 25 kilometers. Whenever an earthquake happens, this graph is plotted to measure the damaging effect of earthquake. We call this graph as seismogram or strong motion accelerogram. In this graph, on the vertical axis, level of acceleration is plotted. On the horizontal axis, time duration of shaking is plotted. So in this earthquake, you can notice that acceleration was close to 500, the peak value, 500 centimeter per second squared or 5 meter per second squared, 0.5 times acceleration due to gravity. And the total duration of shaking was 300 seconds, out of which the middle portion where shaking was maximum was for almost 100 seconds, about 2 minutes, which is a huge, huge value. Magnitude 9, shaking for almost 2 minutes at a peak acceleration of 5 meter per second squared is a huge value. And it was so powerful that Honshu Island, which may be approximately 1/10 of India, that was moved by 2.4 meters. See the power of this earthquake. Shaking continued for nearly 5 minutes. Usually big earthquakes, shaking will not exceed 1 minute. The middle portion, which we call as, strong motion part, will be for about 15 seconds or so. So in this case, the strong motion continued for more than 60 seconds, 1 minute, close to 2 minutes. And there were many aftershocks. Big earthquakes are followed by many smaller earthquakes, which we call them as aftershocks, 400 or so, and some of them had magnitude 7 and above. This caused change in length of the day by almost, 1.8 microsecond. The day became shorter because of this earthquake, which happened way back in 2011. Unfortunately, it killed 25,000 people. Japan was ashamed that so many people were killed. So much of infrastructure was damaged. Many, many houses, 15,000 and above, were completely destroyed, and huge amount of economic loss to the country of Japan. Some pictures from this earthquake. You can see here the pictures taken by satellite. What you see black there is sea. Left side is very serene, it's very silent. Sea is very peaceful. There are green portions on the land, and bluish ones are the shades of the cloud, which you see in the land area, which is more mountainous, away from sea, hilly terrain. But look at on the right side. You see many white patches in the sea, many white patches also in the land. These white patches are things, which are the infrastructure which are hit by the tsunami and which have fallen down. And these waves move upwards from the sea to the land and move upwards till they lose their energy, they lose their speed. And they take away many things, they take away the buildings also upwards. And these waves, this water, they occupy some low-lying areas. And after they move up, they move back to the sea. When they move back to the sea, they take away a lot of things which have fallen into the sea. And what you see here in the sea, that white patches are many things taken away by tsunami into the sea. It could be a building, it could be a bus or anything. And also many white patches on the land indicating seawater inundating into the land. This is how the waves were ferocious, and I was told that, height of some waves were 40 meters. 40 meters means, more than 20 people, height of more than 20 people. And this is how a typical city looked like after the tsunami was hit. Normally, Japanese cities are very, very pleasant, very clean, very well planned. But you can see the mess here. You can see what has happened to these buildings, and so much of water has come in. And one moment, entire thing has changed. Everything was normal just before the earthquake. Earthquake caused tsunami. Tsunami waves came and hit. And see the mess in the city here. You can see here these ships. These ships, came from sea into the land. This is not sea, this is land. You can see motor cars here. Maybe these ships were bored being in sea. They wanted to have a change. They came to the land. With the water, they came inside the city. So many confusing things happen during a disaster like earthquake and tsunami. Here, you have many motorboats here. They are looking for high jump. You can see the wall. This wall is called sea wall, which is mainly to protect the inside of the city from a possible tsunami. They have built these walls, about 6-7 meters high, 7-8 meters high. They didn't expect that a tsunami wave can be so big, 40 meters also. And here, these boats seem to be trying for a high jump to get inside, to get into the land, but they have failed. And the main beauty here is that the wall is intact, no problem at all. So it survived the force of the tsunami, even force of these boats. But the height was small, therefore, there was scope for water to enter into the city. If they had built a 40-meter high wall, they would have protected the city, the inside of the city, from the tsunami waves. Here you see an airport, Sendai Airport, flooded with seawater. You can see totally it is flooded with seawater. And the entire tsunami wave has, simply dumped water in the airport. In the next slide, you see that all this water had moved, or it moved into the sea, leaving behind silt. The thickness, the height of the silt was about 1 meter. It took sufficiently long time for that silt to be, removed. So many indirect problems do happen, which we will not know. Here you see in this picture, aircrafts and cars dumped together in some low-lying area. It looks like, a kid's toys. But this is reality. So a low-lying area, when the tsunami waves came, they dragged all these aircrafts and motor cars in the airport and dumped them into some ditch like this. And this is how strange things can happen during an earthquake. Still, this bridge is intact. There was so much panic, so much, shaking, but this bridge survived, indicating that the infrastructure was well built and hence, there was no problem. So earthquake did not cause serious problem. Only the tsunami was the problem creating one. And even if by chance this bridge also had collapsed, I don't know how much would have been the damage, how much impact it would have made. The other major problem was the nuclear radiation. Like in India and Japan also, there is need for electricity. We have many hydel projects which generate electricity. They are not sufficient. So we have gone in for nuclear electricity production. Kaiga in Karnataka, and also you have Kalpakam in Tamil Nadu. Many such nuclear power plants are there. So this one, Fukushima nuclear power plant, had been serving almost 1/3 of Tokyo. Electricity generated from here was able to help at least 1/3 of Tokyo. And when this tsunami waves came, they hit this power plant so much that the power plant was, damaged, causing a huge explosion, causing nuclear radiation. Friends, please note, nuclear radiation is extremely dangerous. If something like that happens, not just at that instance, but for hundreds of years, effect will be felt. Those who consume nuclear radiation will have some damage, some problem to their health. Their children, grandchildren, great-grandchildren also may have some effect or the other. And this was one of the worst nuclear radiations. People say that it was next only to Chernobyl radiation, which happened in Russia sometime in 1980s. So many people would have been killed because of radiation. Japan has not given the clear indication, clear statistics. Many animals and plants would have been severely damaged. And this is the other indirect effect of earthquake. You can see a mess on the road here. You can see that, a good road has been covered by mud. Because, from the bottom, water has lifted up this mud and brought it up. And that process we call as liquefaction, which may cause lot of casualties, lot of problems. I think, we are almost, I have crossed the time. So I will just take a few other slides I will show you before I allow you for a break. You can see what has happened to this building. This building appears to be okay, but the ground below has failed. This is a sloping ground which has moved, causing a lot of damage to this. And you can see another strange thing here, very difficult to understand. This is a 2-lane road. One of the lanes is intact on the upper side here, but the other lane, it has moved and it is wavy like this because earthquake has changed its ground. Why? Very difficult to imagine, very difficult to explain. But maybe this looks like a slope which is man-made and care has been given in the top surface. It's compacted well. Probably it was less compacted here. But what is very interesting is it appears as if somebody has taken a scissor and cut it into 2 parts. These are some of the strange things which can happen during an earthquake. I think I will continue my lecture after this break because it's always good for me to leave you on time. But before that, if you have some questions, I'll be extremely happy to answer. So over to all of you. And if there are some questions, I'll be very, very pleased to